So there's this massive, heavy, just unforgiving steel wire hanging off the side of a colossal oil tanker.
Right.
And it's stiff, it's awkwardly positioned, and it is dangling exactly 1 to 2 meters above the waterline.
Yeah, exactly 1 to 2 meters.
Right. And for over half a century, this piece of equipment, which is known in the maritime industry as a fire wire or an emergency towing off pennant.
Right. ETOPS.
Yeah, ETOPS.
Yeah.
It's been hailed as a critical, absolutely non-negotiable safety control.
Oh, absolutely.
You would assume something mandated on thousands of ships for 50 years is, there to save lives.
You'd think so, yeah.
But today we are jumping into an August 2026 analysis from the maritime publication, the DeepDraft. And it uncovers a highly disturbing reality about all this.
It really does. It's fascinating.
Yeah. This supposedly vital lifeline might actually be the most dangerous thing on the ship. Like breaking bones and crushing limbs while failing to provide any actual safety at all.
Yeah.
So today, our mission is to get to the bottom of how a global safety rule became a massive workplace hazard.
The history of this requirement is a really fascinating study in how theoretical safety can completely detach from physical reality.
Right.
The author of the DeepDraft piece provides some great perspective on this right off the bat.
Yeah, they do.
They note that when they joined their first tanker as a cadet, this was about 25 years ago, rigging a firewire was treated with almost religious reverence.
Oh, wow.
Yeah. If a ship was being vetted by inspectors, the one observation that every single crew member was terrified of getting was a poorly rigged firewire.
A poorly rigged wire. So the article lays out these intense visual requirements. And it sounds less like engineering and more like, maritime origami.
That's actually a great way to put it.
Because the wire had to be led correctly over the side.
Right.
There had to be exactly 5 figure-of-8 turns on the bits.
Yes.
And those are the heavy metal mooring posts on the deck, right?
Yes, exactly. The bits. 5 turns.
5 turns. And there could be absolutely zero slack on the deck itself.
None.
And the eye of the wire, the loop at the end, had to hover exactly 1 to 2 meters above the water.
Right.
Not 3 meters.
Yeah.
Not dragging in the water. Exactly 1 to 2.
The precision was the entire point of the exercise at that time.
Why?
Well, vetting systems, like the Ship Inspection Report Program, which is commonly known as SIRE.
Okay, SIRE.
Yeah, they relied heavily on this older, very binary inspection logic. You either ticked the box perfectly or you failed the inspection entirely.
Oh, man. So no gray area.
No gray area. And failing a vetting inspection meant the ship might not be allowed to load cargo.
Wow. Which translates to what? Massive financial loss.
Huge. A massive financial loss for the company. So the pressure to get the visual presentation flawless was just immense.
Yes.
It completely overshadowed whether the system actually made any sense in the real world.
I'm trying to wrap my head around the logic here.
Yeah.
Because it feels like grading someone on how neatly they folded a parachute without ever bothering to check if the parachute has a hole in it.
Yes.
Or, that the ripcord is even attached.
Yeah.
You're just looking at a perfectly symmetrical, aesthetically pleasing folded piece of canvas and calling it safe.
That analogy hits the nail on the head. We are talking about a system that prioritized the appearance of readiness over actual capability.
Right.
And when you prioritize aesthetics over function, especially with heavy industrial equipment,
Things go wrong.
exactly,
Yeah.
you run into the core tension of this analysis. If we aren't entirely sure that the perfectly folded parachute even works in a real drop, we have to look very closely at the physical toll it takes on the people who are forced to fold it day in and day out.
Yeah, because the physical reality of this task sounds absolutely brutal.
It is.
Like when a layperson hears firewire, they probably picture a thick rope,
Right.
Maybe something you'd use in a schoolyard tug of war.
Yeah, sure.
But we are talking about large, stiff, greased steel wire cables being manhandled over the side of a steel ship.
Right. We were talking about a highly hazardous manual operation.
Yeah.
You are dealing with uncontrolled movement, immense weight, and critically, stored energy.
Stored energy. What do you mean by that?
Well, steel wire rope has a memory.
Okay.
It wants to coil back into its natural shape.
So it's fighting you.
Exactly. When you are forcing it into tight figure-of-8 turns around a post, you are physically fighting the properties of the metal.
Wow.
And if it slips, that tension releases instantly.
And the crew isn't just setting this up once and walking away, right?
No.
I want to make sure I understand the mechanics of this. Because the article mentions that the crew has to constantly adjust the wire due to the changing draft of the ship.
Yes, the draft.
Can you break down exactly what that means in a practical sense?
Sure. So simply put, the draft of a ship is how deep it sits in the water. An oil tanker is essentially a giant floating steel container. When it arrives at a terminal empty, it sits very high up out of the water.
Makes sense.
But as it pumps millions of gallons of crude oil into its tanks, it becomes exponentially heavier.
Right.
And so the ship naturally sinks deeper into the ocean.
Ah.
Meanwhile, on top of that, you also have the natural rise and fall of the ocean tides occurring simultaneously.
So the water level itself is moving and the ship is sinking lower.
Exactly.
So if the rule dictates that the eye of the steel wire must remain exactly 1 to 2 meters above the waterline, the crew is constantly fighting a moving target.
Precisely. As the ship sinks lower from the cargo weight, or as the tide changes, the wire gets closer to the water.
Yeah.
To maintain that perfect 1 to 2 meter gap for the inspector, the crew has to go out onto the deck.
Over and over.
Over and over, often in the rain, at night, on a slippery surface, and they physically haul that heavy steel cable back up.
Oh.
They readjust the 5 turns around the bits, and they secure it again. And they do this throughout the entire duration of the port call.
That sounds like a recipe for a musculoskeletal disaster.
It really is.
And the data from the DeepDraft piece backs that up in a way that, honestly, completely blew my mind.
Yeah, the sheer volume of the injury data is sobering.
Yeah.
The Singapore Shipping Association published a review in 2009 and 2010.
Okay.
They looked at an assessment commissioned by the Oil Companies International Marine Forum, which is OCIMF.
Right, OCMF.
And it was carried out by Lloyd Sellers' Register. The findings showed that over a 42-year period, there were approximately 17,000 injuries to seafarers, specifically related to using these firewire.
Wait, 17,000?
17,000.
That is an astronomical number for a single piece of supposedly safe equipment.
It's massive. It averages out to more than one seafarer getting hurt every single day for 4 decades. Now, to be fair, the article does note a separate technical document from the China Classification Society.
Okay, what did they say?
They cite a lower, more conservative figure of about 1,700 personnel injured while handling these wires.
1,700, okay, so quite a bit lower, but still.
Still huge. The overarching conclusion remains completely undeniable, regardless of which data set you lean toward.
Right.
The handling of these wires creates severe, predictable harm to the human body.
Let's talk about the nature of that harm. Because saying injury sounds very clinical, you know?
Yeah, it does.
But the sources give specific examples of what happens when crew members wrestle with this equipment. The Port of Richards Bay actually wrote a warning into their emergency plan.
They did.
Because they were seeing so many strain injuries, spinal complaints, and severe muscular back injuries from crews leaning over the rail to heave this steel.
And the trauma can be much more acute than just muscle strains, too.
Right.
The author notes a personal observation of a crew member sustaining a severe leg injury during rigging. There is also a highly publicized Isle of Man casualty summary detailing an oil tanker where a firewire actually slipped during a manual recovery operation.
Oh, no. Because of that stored energy you mentioned.
Exactly. The stored energy released, the wire snapped back, and it completely crushed a crew member's leg against the deck machinery.
That is horrific.
It's terrible.
Which brings us to the kicker, the absolute craziest detail in this entire analysis.
Yeah.
Despite the thousands of crushed limbs, ruined backs, and severed fingers, there is zero documented evidence of a firewire actually being used in a practical emergency since 1967.
Zero.
Zero.
It is a stunning imbalance. You have thousands of documented human casualties on one side of the ledger.
Right.
And zero documented practical saves on the other.
Okay, wait. I am stuck on something here. 1967. If nobody has ever used this successfully to save a ship in over 50 years, how did it become the unquestioned global standard in the first place? Didn't regulators test this theory before mandating it on thousands of massive industrial vessels?
Well, you have to look at the mindset of the 1960s maritime industry.
Okay, set the scene.
This was an era of rapid expansion. Ships were suddenly getting much bigger, oil terminals were expanding, and the fear of a massive terminal fire was very real.
Sure.
The concept of the firewire made intuitive theoretical sense on paper.
On paper.
Right. The idea was simple. If the terminal catches fire, the crew might have to abandon the ship, or they might be incapacitated.
Okay.
So if they leave a wire hanging over the side, A heroic tugboat captain can drive up, grab the wire, and pull the burning ship away from the dock to save the facility.
I mean, it sounds like an action movie plot.
And that is exactly the problem. It relies on action movie physics.
Right.
Regulators mandated the visual control without ever rigorously testing the mechanical reality of pulling a modern 300-meter-long, fully loaded oil tanker away from a dock by a single wire.
While it's still tied up.
Exactly. While the ship is still tied up with its regular mooring lines and connected to metal cargo loading arms.
It's insane. So if the data is this damning and the physics literally don't work, why on earth is it still happening today? Like, why are seafarers in 2026 still crushing their fingers for a 1960s action movie theory?
Because we are currently witnessing a massive bureaucratic standoff.
Between who?
Between global authorities and local terminals.
Okay.
At the highest levels of maritime governance, the experts have actually woken up to the data.
Well, they have.
Yes. The current global framework, specifically OCMF's SIRE 2.0 and the International Safety Guide for Oil Tankers and Terminals, which is known as ESCOT T6.
Got it.
They have completely moved away from this detailed obsession with firewires.
That's great.
The old sections from the previous manual that mandated the 5 turns and the specific water clearance, those have been officially marked as withdrawn.
Okay, so the top global experts are loudly broadcasting, hey, stop doing this, it's hurting people.
Exactly.
But the injuries haven't stopped.
They haven't stopped because local ports and terminals are fiercely guarding their legacy rules. A global guideline is ultimately just a guideline. The local port authority owns the water you are parking in.
Right, their house, their rules.
Precisely. If they say you need a wire, you rig the wire, or you don't do business.
Wow.
For example, Saudi Aramco's 2025 port rules still explicitly mandate fire wires forward and aft.
In 2025?
Yes. They still demand that precise 1960s style presentation, 5 figure of 8 turns, no slack on deck, 1 to 2 meters above the water.
It is a jurisdictional nightmare for the ship.
It really is.
You have a captain commanding a multi-million-dollar vessel carrying the exact same hazardous cargo, operating under the exact same scientific emergency principles.
Yeah.
But depending on which side of an ocean they park on, they get a completely different set of safety rules based entirely on local bureaucracy.
Which highlights the author's core argument about the illusion of safety, and specifically, the reversal of the burden of proof.
What do you mean by that?
Well, the traditional firewire arrangement is incredibly easy for a local terminal inspector to check.
Right.
They can just walk along the dock, look down, count the 5 turns on the steel post, verify the height above the water, and check a box on their clipboard.
Easy.
The ship has proven it can comply with the checklist.
But the terminal never has to prove they can actually do their part.
Exactly.
It's a safety theater. It is the maritime equivalent of taking your shoes off at the airport security line.
That's a perfect comparison.
Right. Everyone goes through the motions. It looks like a highly secure process, and you are rigorously following the checklist.
Yeah.
But does taking your shoes off actually stop a modern threat? An inspector, seeing a wire hanging perfectly, doesn't magically guarantee a tugboat is actually going to be there to pull the ship to safety.
You've hit on the exact flaw in the system. A correctly rigged fire wire just proves a local instruction was followed.
Yeah.
It does not prove emergency capability.
Right.
If a major terminal requires a ship to expose its crew to physical harm to rig a wire, that terminal should be required to explain how the rest of the rescue will actually work.
Exactly.
Because true emergency towing requires a massive coordinated system.
What does that actual system look like in reality, outside of the theoretical checklist?
It is incredibly complex. First, you need tugs of sufficient horsepower on standby, ready to maneuver into a potentially burning area.
Okay.
You need coordinated firefighting capability covering the dock.
Right.
The terminal must have a rapid emergency release system for the metal loading arms pumping the oil. Otherwise, you'd rip the pipes apart and cause a bigger spill.
Oh, man. Yeah, that would be a disaster.
You also need a way to release the ship's dozen other heavy mooring lines safely. You need secure radio communications between the terminal, the ship, and the tugs.
Wow.
And most importantly, you need documented drill evidence proving all these moving parts can act together in minutes.
So if the terminal doesn't have all of those elements perfectly synchronized,
Mm.
that steel wire dangling over the side is completely
That's
useless.
totally useless.
It's just heavy decoration.
That is the danger of the checklist mentality. The old firewire requirement allows one easily visible item to become the sole focus of a safety inspection,
Right.
while the much harder, vastly more important questions about terminal readiness remain completely unanswered.
Yeah.
Removing firewires doesn't mean removing emergency preparedness. It means forcing the terminal to actually manage the real, complex emergency system instead of just hiding behind a piece of steel rope.
It makes you wonder how we break this cycle. Like, are ships just doomed to keep crushing seafarers' fingers forever just to satisfy an inspector's clipboard? What are the actual alternatives here? Do shipping companies just refuse to go to ports that demand the wire?
Well, refusing to trade isn't economically viable,
Right.
but some players in the industry have taken the initiative to solve the problem directly. The first alternative is simply having the courage to abandon the practice entirely based on modern risk assessments.
Okay, who is actually doing that?
Associated British Ports in South Wales is a great example.
Oh, really?
Yeah, they issued a notice to mariners that completely removed the firewire requirement for tankers berthed alongside their docks.
Wow.
They looked at the data, accepted the risk assessment that these wires were injuring people without providing any benefit, and they just stopped asking for them.
That's amazing.
Yeah.
And the article also mentions Freeport LNG taking a similar stance, right?
Yes, Freeport LNG explicitly states in their terminal regulations that a ship's firewires are not required at its docks. They don't rely on the illusion of a wire. Instead, they rely on standby tugs and actual demonstrable firefighting capability as part of a comprehensive marine operations model.
I mean, that is the logical approach.
Hmm.
But we know bureaucracy moves slowly,
Very slowly.
and some port authorities are going to stubbornly insist that they still need a physical way to tow a ship away in an emergency. If they won't drop the requirement, how do we protect the crew?
That is where we turn to the second alternative, the design route.
The design route.
Yes. If a system is inherently dangerous to operate manually, you engineer the hazard out of the process entirely.
Oh, I see.
And Japan provides a brilliant, highly effective example of this approach.
The recessed bits.
Yes,
I found this part of the analysis absolutely fascinating from an engineering standpoint.
it really is. The Japan Coast Guard's navigation guidance is kind of a masterclass in bridging legacy rules with modern safety.
Right.
Technically, they still require emergency towing capability for dangerous cargo vessels in certain designated Japanese waters. However, they offer a very specific engineered exemption.
What is it?
If a tanker is fitted with sunken or recessed bits of verified strength, the ship is completely exempt from having the crew manually rig a firewire.
Let's paint a picture of this for the listener, because the mechanics of it are brilliant.
Yeah, go ahead.
Instead of having those heavy metal posts standing up tall on the main deck where the crew has to drag the wire, fight the tension, hang it over the railing, a recessed bit is built directly into the side of the ship's steel hull.
Right.
It is essentially a reinforced, sunken pocket with a strong, smooth attachment point safely tucked inside it.
It is a pure application of design basis discipline. You are moving the safety control from a manual, human-operated procedure to the physical architecture of the vessel itself.
That makes so much sense.
Modern mooring logic dictates that you engineer the solution into the interface between the ship and the terminal.
Right.
By designing a sunken pocket in the hull, naval architects can certify the exact safe working loads of that steel. They can verify the structural load paths, ensure these attachment points are located perfectly forward and aft, and guarantee that a rescue tug has direct, clear access to hook onto the ship.
Without any crew member ever touching a piece of wire rope.
Exactly. Without anyone touching a wire.
It is so elegantly simple. If an authority demands an emergency tow-off capability, it should be permanently built into the structural design of the ship.
Yes.
It should never depend on a crew of exhausted humans improvising with greased steel in the middle of the night.
That is the ultimate defining takeaway of the DeepDraft analysis. Japan as policy acknowledges the legacy desire for a tow-off point, but their structural exemption proves that proper engineering can entirely eliminate the need for dangerous manual rigging.
Yeah.
A true safety culture should never protect outdated legacy procedures at the direct expense of human bodies.
When you look at the entirety of this deep dive, the conclusion is overwhelming.
It is.
You have a severe, heavily documented handling hazard that exposes seafarers to crushed limbs and spinal injuries.
Right.
You have public industry data proving this happens constantly, to the tune of thousands of injuries.
Yeah.
And you have a 50-year historical record showing zero documented practical use for the equipment in an actual emergency.
Zero.
It is a staggering failure of risk management.
As the author bluntly points out, until local terminals can prove they have a comprehensive emergency system in place involving synchronized tugs, communications, and emergency release protocols, and stop simply inspecting a ship's deck rigging, a firewire cannot be called a safety device.
Well,
It is just a heavy steel reminder that the shipping industry sometimes protects its bureaucratic checklists much better than it protects its seafarers.
So we started today looking at a hyper-specific maritime rule. Rig a wire, make 5 turns, keep it exactly 1 meter above the water.
Right.
What we uncovered was a half-century-old hazard sustained entirely by a stubborn clash between global logic saying stop and local clipboards demanding compliance. We've seen how terminals in South Wales and structural engineers in Japan are finally breaking that cycle by designing the hazard out of existence.
It is a powerful lesson in institutional inertia, but it also leaves us with a highly relevant question as we look toward the future of heavy industry.
What's like that?
Well, we are rapidly moving into an era of automation and AI where computer algorithms and digital dashboards are increasingly dictating operational procedures.
True.
If highly trained humans in a global shipping industry unquestioningly enforce a dangerous, purely theatrical manual task for 50 years just because the rulebook said so,
Yeah.
what happens when an AI optimization algorithm dictates a physical task that looks perfectly safe on a digital spreadsheet, but puts a skeleton crew in physical danger on the ground?
Oh, man.
Who is going to have the authority to push back against the computer and say, hey, this checklist is breaking our fingers?
That is a terrifying but very necessary thought. The perfectly folded parachute doesn't matter if the algorithm doesn't know it's crushing the packer's hands. Something to keep in mind the next time you see a massive, stiff steel wire hanging uselessly over the side of a ship, or honestly, just a perfectly checked box on any compliance form. That's all for this deep dive. We'll catch you on the next one.